This is, oops, I'm going to go through the worksheet we had on regression. This is the idea of exploring association between two quantitative variables. And it's the thing we did last in class. And there will be a sort of basic questions about this on the exam, but nothing too detailed. But I did want to take a chance to go through this so that if you are working on online assignment F, you have something to base it on. So the front of the worksheet, we went through the first question on there, and the second one looks like this. We have study time versus GPA for for 8 students, and the problem is shown as it appears in MyLabs Plus down here. This is the problem that we're pulling things from, and when you open one of the problems in MyLabs Plus, it'll have this little icon here that allows you to open up the data, either in a spreadsheet, or you can just copy it, or you can go straight into StatCrunch. And if you do that, if you do any of those things, it should take you directly into it. But I know that some people have had some issues with StatCrunch opening correctly, depending on how they go into it. So I wanted to show you an alternative if StatCrunch is not working like you want it to. The easiest thing to use is StatCrunch if it'll open right. Anyway, so just to get the problem started, I copied the data onto the table at the top of the page here. And I went ahead and drew the points over here. And as we discussed in class, the points are just using these two things to decide how far over and up to go. So when it says study time 4, that means we're walking along the study time line to 4. And then we're headed up to the GPA of 2.5. So this point right here, we would say has coordinates 4, 2.5, meaning go over 4 and up 2.5. And so each point is drawn in that way. And we can see, looking at it, that there seems to be at least a pattern to the points, in the sense that as the study time goes up, the GPA is going up. So we'd expect, if we do ask this to draw a regression line, that it's going to draw a line that kind of goes through there like that. Remember, it's the line that comes the closest to all the points. So it'll always sort of go through the middle in a way that minimizes the total distance from the points. Those points are fairly close to the line, and so I would say that that's a fairly strong correlation. That certainly doesn't look random. One of the questions you'll have is, when would we say the association is weak, and when would we say it's strong? And it really is just a matter of opinion for the most part. There's not really a real cutoff, but we'll see that the correlation coefficient R at least gives us some guidance on that. Anyway, so we can see the questions here. Write the equation, find the correlation coefficient, decide if it's strong or weak association. I can already tell that the association is positive. That just means that this line is going up from left to right instead of down. But to answer the other questions, I really need to go into the software. At no point will we really ever have to do this without the software result. So let me show you what happens if we put this data into the alternative software package. The link you see at the top of the page, there's a page of, oh, cat's on the table. Hey, kitty. The URL at the top of the screen here is also linked from D2L. In D2L, there's a link that says to web apps, and this is a list of them. So the one for linear regression is this thing. So when you're in this web app, if you tell it that you want to enter your own data, it gives you a chance to name your two variables. So we could put study time here and GPA here. They should correspond to the horizontal and vertical axes. And then you can just literally grab the data out of you can do the copy and paste thing and just put your mouse in here and paste, and it will actually fill correctly. It's only 8 data points, so it wouldn't take forever to type. And then you hit submit data, and then this is what it looks like. So you can see here, I've given the names so that they show up where they're supposed to show up. All the points are here. I've clicked show the regression line, which is what's drawing the blue line through here. And then over here, it tells us everything we need to know about the regression and about that line. So in particular, it will tell me the the equation of the regression line, and you'll often see it written like this. You'll see y hat, that little thing over the y, we call that a hat, is 2.48, just rounding that off, plus 0.056x, like that. The term intercept is referring to what you use as the y-intercept in algebra class. That's the thing that does not have an x with it, and then the thing that says slope is the number that goes in front of the x. If you're not sure about that and you're using this app, you can look up here at the top, and it's written out for you in slope-intercept form. The reason that it calls it y hat is that they want to make a distinction between the values that this thing predicts, the y values this predicts, versus the actual y values of the data. So each data point has a y coordinate, a real y coordinate that goes with it, and then this y hat is a predicted y coordinate, and the prediction is going to be coming from this line. So y hat are y coordinates along the line, and when we use y, we're talking about the actual y coordinates of the dots. So they do that just to distinguish between the two. You can just kind of, I don't think there's ever a time where it's confusing which one you're working with. So if you leave it off, it's not a big deal. Leave off the hat, it's fine. The other thing we can see here is the correlation coefficient. This is the R value. And remember, that's the thing that we said is always between -1 and 1, always. And we said R equals 0 means that this is just random crap. In other words, R equals 0 is what it would look like if your dots came from just like spritzing water on the screen or sneezing on the screen or something. R equals 1, it means it's a perfect fit to the points. Perfect fit to a positive line. And R equals -1 is a perfect fit to a negative line. Negative meaning that the line's falling from left to right as opposed to growing from left to right. So we can tell from the fact that the R here is positive that the line should be going up from left to right, but we can see that it is. So that's a positive association. And that's what we said before, we could see it. And that R is fairly close to 1. It's certainly closer to 1 than it is to like a half. So I would say this is a strong positive association based on the R value. If your R value is more in the sort of 0.4, 0.5, 0.6 range, then you might say there's a moderate association. And if your R is down by near 0 or 0.1 or 0.2, then you would say there's a weak association or really no association. The closer it is to 0, the closer the R is to 0, the less association you have. So it's not a problem if it's negative. That just means your line is going down. But if your R is close to 0, then you have very little connection. So the reason that we care about that is because we would like to use this equation that we wrote down to make predictions. So using this to make a prediction would be like on the worksheet. I would say if someone has study time of 9, someone says they're going to put in 9 hours of study time, then the prediction is the prediction will be GPA, that's what the y coordinates are, is about 2.48 plus 0.056 times 9, whatever that is. So that number, it's about 3. Who am I kidding? Anyway, it's around 3.1, maybe 3.2. So that's the GPA prediction for someone who puts in 9 hours of study time. And what that means in terms of the graph is if you come over to 9 for study time and go up to the line, then we're saying that the line, its y coordinate, is, 3.1 doesn't sound right, does it? Oh, must be closer to 3.0. I'll say it's close to 3.0. Anyway, you can use a calculator. I don't have a calculator in front of me, so whatever that is. But what it means is it's the y coordinate on the line above 9. So if you get 9, go up to the line and go over, that's the GPA that you expect with a study time of 9. And since there's no data point that corresponds to 9, that would be as good a guess as any. I think that's all the questions that it asked. Let me just see. Yeah. Okay. And then on the back side of the page, there are some more exercises that really are getting more at vocabulary. The first one is about explanatory versus response variables. So if you were looking, for example, at used car price versus used car mileage, you would think that the mileage on the car, meaning like how many miles the car has on it, 100,000 miles, 120,000 miles. What we normally think of is that more mileage reduces the price. The more mileage would it be, the car should be cheaper. And so when we think of it that way, that the increase in mileage is causing a reduction in price, then that indicates to us that this should be the explanatory variable, and price should be the response variable. Similarly, in B, we think that the number of absences in a class affect the class grade. So we don't really think the class grade affects your number of absences, but we think the number of absences affects your class grade. So the same way the other one worked, we expect this to be explanatory and this to be response. Now, there's a lot of situations where they're more or less the same, and there's not an obvious way that you could say that one causes the other or one explains the other. And so sometimes you could argue for it to be the other way around. But generally, we want to decide which one's which before we do our analysis because, for example, when we have a graph, we're going to put explanatory, whatever the explanatory variable is, across the horizontal axis. And we're going to put the response variable on the y-axis. So just to make sure we all have the same picture, it's worth at least saying out loud, which one we're going to consider to be explanatory and which one we're going to be considered response. Okay, then this other problem is it's giving us some different scatter plots so that we can see some different values of R. And I'll send you a web app that allows you to practice this, but it's not too complicated. Basically, you just want to draw the line that you think comes closest to everything, and then ask yourself how far off that line are your dots. And for the first one, the answer is not very far at all. So this must have a pretty high R value, and the line I drew is positive, going up from left to right. So I expect the R value here to be a fairly large positive number, and so that would be this guy. That's almost 1. The next one, it's actually a little hard to tell whether you should draw the line this way and miss those points or whether you should draw the line this way. But the second one actually comes closer to more points. But the ones it misses by quite a lot. This line is falling from left to right, so it definitely has a negative R value. And since so many of the points fit well, we expect that the R value is pretty close to -1, which is as far away as it could get from 0. But it's not going to be all that perfect. So that'll be this one, a negative number that's almost perfect. And then this one, I'd say the line that goes through is about like that. And for this one, The line that goes through is probably about like that. Not too great. And so you can see that last one is probably the worst one. And it definitely is a negative. So negative 0.42 is going to be that value of R. And notice how when you get to that range of, 0.3, 0.4, 0.5, it really starts to not look all that, doesn't seem like it fits all that well at all. And so that means that 0.72 will be this guy here. The points aren't really close to it, but we definitely have a positive slope. So I think that's probably enough. If you have questions on other problems on here, just hang on to them. We'll talk about them on Tuesday. But I wanted you to have this sooner than later, so that you would be able to get into the homework problems F and feel like you had some examples to work from.